All right, so this is the last problem we're going to do today. What I want you to do is watch hopefully you've watched all the videos. There's 4 of them because I split one of them. So a boat's moving at a constant velocity of 3.5 meters per second. Excuse me, horizontally. I'm a little tired. While accelerating vertically at 0.8 meters per second squared for 7 seconds. All right, so as you can see, I already have drawn the XY axis chart. So let's start to look at the numbers that we have. We look at the numbers that we have. So the first one, we have a constant velocity of 3.5 meters per second. Horizontally, which means it's going this way. So 3.5 meters per second is going to be the initial velocity, the final velocity, and because these are the same, the acceleration is going to be 0 meters per second squared. We get all of that from those 5 words right there. We get 3 answers in our chart from those 5 words. Okay, so now it says that it's accelerating vertically at 0.8 meters per second squared. Well, we know the vertical axis is y, so it's 0.8 meters per second squared. Okay, for 7 seconds. So 7 seconds, because time doesn't happen in a vacuum, 7 seconds is going to be the time for both the x-axis and the y-axis. All right, so now you have that. You filled in almost everything that you know, except for one thing. What should the initial velocity of y be? 0. Okay, the initial velocity is going to be 0. And as we get deeper into these lessons, you'll see why that is the case. Okay, so now you only have 3 things to solve for. So first things first, let's just do dx. dx equals vi times t plus 1/2 of at squared. dx equals 3.5 times 7 plus 1/2 of, 0. We're done. Okay, so d of x equals 24.5 meters. So it's traveled 24.5 meters for the x-axis. All right, so a couple things. You can solve for final velocity of the y-axis. That's easy. Vf equals vi plus a times t. So Vf is going to equal 0.8 times 7. Well, 0.8 times 7, 0.8 times 7, 0.8 times 7 is 5.6 meters per second. So Vf equals 5.6 meters per second. All right, and now we just have to solve for the distance or the displacement of the y-axis. So hint here, velocity is positive, acceleration is positive. Which way is the boat moving? It's probably moving, the land is probably getting what? Higher. So your number here should also be positive. So d of y equals vi times t plus 1/2 of at squared. dy equals, this is going to be 0, so that cancels, plus 1/2 of 0.8 times 49, because 7 squared is 49. 49 times 0.8, one-half of 39.2. 39.2 halved is dy equals 19.6 meters. And that's it. So we know that's moving upward. We know that's moving positively forward. That's it. So the biggest key of what you need to do here, the biggest key of what you need to do is just make sure you take out the pieces. You need to read the problem and comprehend what's happening. Don't be so hell-bent, oh my God, I gotta get an answer, gotta get an answer, gotta get an answer. No, stop doing that. Read what you have. Because some of you would have said, oh, a boat is moving at a constant velocity of 3.5 meters per second. You just would have filled that in as the initial velocity and be like, well, what's the acceleration? What's the final velocity? Not taking into account constant means it's going to be the same, which means there's no acceleration, zero acceleration. All right, and then this tells you vertically, this is what it's doing acceleration-wise. And again, your hints, remember your units. Velocity, meters per second. Acceleration, meters per second squared. Time, seconds. Displacement or distance, meters. You got to remember those, because if you don't remember those, this becomes way more difficult. Way more difficult. All right, so because sometimes I see you guys writing the acceleration in for velocity. That's not the case. It can't be. It can't be meters per second squared to be velocity. All right, so I'm going to post probably 2 or 3 practice problems. Again, it's going to be graded on effort. Make sure you try. Draw your graph, draw your chart, or I'll have the charts on there. Make sure you draw your diagram of what's happening and things of that nature, all right? So give it a shot. If we're not in tomorrow, if we are, great. If we're not, even better. And then we'll go from there. So like I said, this will be graded on your attempt, not on accuracy, all right? Put your PJs on backwards, put the spoon in the bathtub or toilet or whatever, pray for snow, and go birds.